All right, so now that we know how to balance equations, we're going to combine using moles to convert things and what that means when you're given a chemical reaction. So we're kind of taking everything and putting it all together. So let's take a look at this example we have here. So we're given a balanced equation. And these numbers, like I said in a prior video, the coefficients tell us how many moles of something we have. So that means I have 2 moles of H2, not just 2 molecules of H2. There's nothing in front of the oxygen, so that means I have just 1 oxygen. And with 2 moles of hydrogen and 1 moles of oxygen, I can make perfectly 2 moles of water, right? So you want to think of chemical reactions like a recipe. Let's say I was baking cookies. If I wanted to double the amount of cookies I was making, I would have to double every single ingredient, right? If I wanted to triple the recipe, I would have to triple everything on the ingredient list. So when you're looking at a balanced equation, if they change one of the amounts of something in the reaction, you have to change everything else in the reaction by that same factor to keep it balanced. So right now this is balanced, but they're saying how many moles of H2 are produced when 5 moles of oxygen react. So I'm changing my amount of oxygen to 5. I'm going from 1 to 5. So that means that I'm going to be changing the amount of water that I can make. Okay, so how would I do it? Let me erase this 5 so that it's not here confusing you. Just like with converting units, guys, you always want to start off with what you're given. You're given 5 moles, and now that you have a whole reaction, it's important to write what substance we're talking about. So what we're given is 5 moles of O2. And I want to change this into moles of H2O. So I need to come up with a conversion factor, and I get that conversion factor by looking at the coefficients in my reaction. So I want to get rid of moles of O2, so I'm going to put that on the bottom, and I want to get to moles of H2O. So literally you just look at what the coefficients are. I have 1 O2 and 2 H2Os, so I would put a 1 on the bottom and a 2 on the top. Moles of O2 cancel out, and I'm left with moles of H2O. So mole to mole ratios, when one thing changes, everything else has to change by the same factor, and you use the coefficients in the reaction to cancel out units. All right. So what really though we're going to be looking at, guys, so if someone tells you, oh, you need this many moles of this, that's not really helpful to us because there's no piece of equipment we can use in the lab that can tell us how many moles of something we have. What we actually get in lab is we get masses of things, but to figure out how much of something we're going to need or how much of something we're going to make, to go from one substance to another, we always have to go through moles first. Just like with our mole map, we had to go through moles to change to a different kind of unit. When you're given a whole reaction, you have to go through moles to turn into a different substance in the equation. Okay, so this chart kind of shows you that, but I think it's easier to kind of just look at an example. All right, so again, whatever you're given, 85 grams of oxygen, that's what I want to start with. And because it's a whole reaction, it's important that I write oxygen there because there's a lot of stuff in this equation that the question could be asking about. You need to be more specific now. All right, so what they want to know though is how many liters of H2O gas will be made if I start with 85 grams of oxygen. So not only do I have to convert from grams to liters, but I'm starting with oxygen and I want to end up with liters of water. okay? So always, always, always figure out how you can get to moles first. So if I have the mass of oxygen and I want to change that to moles of oxygen, I know that 1 mole of O2 weighs 32 grams. And I get that, the gram formula mass, I get that from the periodic table. Now that I have moles of O2, my question wants to know about water. So I want to get rid of moles of O2, and I want to figure out how much water that is. So I would look in my reaction. I have 1 O2 and I have 2 waters. So grams of O2 cancels out, moles of O2 cancels out. Now I have moles of H2O, they want liters. Because this is a gas, I can use that 22.4 liters of H2O would be 1 mole of H2O. Moles of H2O cancel out. And if you multiply across and then divide by 32, you guys should all give that a try. I got 119 liters H2O. So now we're back to using our mole conversion factors and the coefficients in a balanced equation to figure this out, because this is the stuff we would be given or want to know in real life, not how many moles of something we have. All right. In our next video, we're going to talk about when we don't have the perfect amount of reactants to start with, but I'll give you one of these to try in the meantime.